So today, we're going to talk about a piece of engineering that honestly sounds like it shouldn't work. We're talking about a machine that can grind materials into microscopic dust, but without any grinding parts. Yeah, you heard that right. It's called the fluid energy mill, and it solves a surprisingly critical problem. But to really get how it works, we first have to understand the challenge it was built to solve.
Okay, imagine this. You've got a breakthrough, life-saving drug, but it's incredibly fragile. The tiniest bit of heat, the kind you get from normal friction in any grinding machine, would literally destroy it. So how in the world do you turn that drug into the superfine powder you need for it to work, without basically cooking it in the process?
And this isn't some small niche problem. This is a huge deal in pharmaceuticals. Think about an inhaler. For that medicine to actually get deep into your lungs, the particles have to be unbelievably small. Or for a steroid to work fast, it needs to dissolve almost instantly. And then you have classics like penicillin, which are super sensitive to heat. The official term for this is thermolabel, and it's a massive headache for drug manufacturers.
So, what's the solution? Well, it sounds like a riddle, right? A mill that doesn't actually grind. Instead of using brute force, crushing and crunching, the fluid energy mill takes a completely different and way more elegant approach. It harnesses the power of nothing more than air itself.
This slide really gets to the heart of it. On the left, you've got your traditional mill. It's all about mechanical force, gears, pressure, friction, and a whole lot of unwanted heat. But on the right, the fluid energy mill just gets rid of all that. It uses jets of high-speed air to make the particles smash into each other, which generates practically no heat at all. It's a complete game changer.
So, how does this magic actually happen? Well, it boils down to two key principles. The first one is impact. I want you to picture millions of tiny particles all accelerated to insane speeds inside a chamber. They're not hitting a wall or a grinder. No, they're colliding head-on with each other. It's like a microscopic demolition derby, and they just shatter themselves into smaller and smaller pieces. And the second principle is attrition. While all those high-speed collisions are happening, the particles are also getting whipped around in this violent vortex of air. So they're constantly rubbing, scraping, and wearing each other down. It's like a tiny, contained sandstorm where the particles themselves are doing all the work.
And here's the kicker. All of this chaos happens inside a chamber that has zero, and I mean zero, moving parts. It's just a cleverly shaped space and a ton of compressed air. So how is this particle vortex actually created, and how do you control it?
All right, let's break down the main parts. First, you've got the grinding chamber. That's the arena. Then you have the high-velocity nozzles, which are like tiny jet engines blasting air in to create that vortex. The feed inlet is simple. It just drops the raw material into the storm. And then, maybe the most important part is the particle classifier. Think of it like a bouncer at a club. It's super picky and only lets the particles that are small enough get out.
So let's follow the journey of one particle, shall we? It gets dropped in. Whoosh! The air jets create this intense spiral. The particles start smashing into each other through impact and attrition. The super fine dust that's created is light enough to get sucked up towards the classifier. If a particle is tiny enough, it gets through the exit. But if it's still too big, it gets thrown right back into the vortex for another round. It's a brilliant, self-correcting loop that just keeps going.
So after all that spinning and smashing, what do you actually get? Well, the final product is what makes this whole technology so vital, especially in pharma and other high-tech fields.
A fluid energy mill can produce powders with particles as small as 1 micron, and in some setups, it can even get into the sub-micron range. That is an absolutely incredible level of fineness and, just as important, consistency.
To give you some perspective, just picture a single strand of your own hair. This mill creates particles that can be 100 times smaller than that. That's how small they have to be to get deep into your lungs from an inhaler or to dissolve instantly in your body for maximum effect.
Okay, so let's just recap the big wins here. No moving parts means almost no wear and tear, and more importantly, no contamination of the product. The lack of heat makes it the only choice for those sensitive thermolabel materials we talked about. Since it's a totally closed system, you can safely handle some pretty nasty stuff inside. And of course, you get that ultra-fine, super consistent output that no other method can really touch.
But, nothing's perfect. As cool as this technology is, that level of precision doesn't come for free. The fluid energy mill definitely has some pretty big trade-offs, which is why you don't see it used for everything. So what's the catch? Well, the biggest one, by far, is energy consumption. Creating that much high-velocity compressed air takes a huge amount of electricity, which makes these mills really expensive to operate. They're also not great for really hard or abrasive materials. They're built for finesse, not brute strength. And lastly, whatever you put in has to be completely dry, which sometimes means adding a whole extra step to your process.
And this quote really sums it all up, doesn't it? This machine basically exchanges mechanical force for fluid energy. You get this incredibly precise, delicate result that's impossible otherwise, but you pay for it with a massive energy bill. It's a specialized tool for jobs where that precision is absolutely worth the price.
So it really makes you wonder, right? This tech is essential for modern medicine, for sure. But in a world that's obsessed with making everything smaller and smarter, from electronics to new materials, where else could a machine that grinds things with nothing but air completely change the game? It's a powerful idea to think about. Thanks for tuning in.